Alright, as we begin this NTI day, you want to pause the video and make sure that you have all the materials you need. Make sure that you have a piece of notebook paper or just a blank piece of paper to take notes. Taking notes is required. That's something that you'll need to turn in. You also want to make sure you have a pencil or something to write with, and if you'd like to have a calculator, that's fine, although you don't necessarily need one. So take a moment, pause the video, make sure you have all your materials before we continue. Once you're all set and you have those materials, you want to begin by writing down the title of the lesson at the top. So the title of our lesson is Spring Semester Day 1, Slope and Linear Equation Review. We're actually going to start off this semester by taking some time to look back on some topics that we struggled with a little bit on the final back in December to make sure that we are confident moving forward. These are topics that tend to show up in future math classes like Algebra 2 and Pre-Cal, so we need to make sure that we're confident in them. Today we're going to focus on slope and linear equations. So once you have that title written down, here we go. So you want to make sure that in your notes you are not just writing down the work, but that you are writing down the directions and the original questions. It's going to be really clear to me who listened carefully as to what they were supposed to do and who didn't. So I'll make this very clear. Take a moment and write down the directions as well as the original question. So together, let's write down the directions that say, find the slope of the line through each pair of points. And number one, right here. If at any point I go too fast, you can always pause the video to write those things down. But you are required to earn full credit to write down the directions as well as the original questions. All right, let's begin. Each of these four questions are asking us to find the slope. Let's remind ourselves of the slope formula. Slope formula is m equals y2 minus y1 over x2 minus x1. That is rise over run, or change in y over change in x. So as we calculate that in number one, right, y2 minus y1, that would be 9 minus a negative 9, so that's plus 9, over negative 16 minus 20. Right, we end up with 18 on top. We end up with, what, negative 36 on bottom. And you should be able to reduce that fraction. You can divide them both by 18 and get negative 1/2. Okay, now let's try number 2. In number 2, we're going to use the same formula, y2 minus y1. In this case, that's 12 minus 12 over 16 minus 10. You already can see that in the top, you're going to end up with 0. And in the bottom, you're going to end up with 6. Now, this is important for us to remember. In which case is the slope 0, and in which case is the slope undefined? When 0 is in the numerator, like you see here, that means that our fraction equals 0. 0 divided by 6 equals 0. However, we cannot divide by 0. 0 in the denominator leads to an undefined slope. Okay? Remember, a slope of 0 looks horizontal. Okay? All right, now let's try number 3. We'll use the same formula, right? y2 is negative 11 minus y1, which is 20, over negative 7 plus 7. You can see we're going to end up with 0 in the denominator. Let's go ahead and figure out what's in the numerator, though. We get negative 31. But negative 31 over 0, while that shows correct work in getting here, is not your final answer. Your final answer should be the word undefined. So make sure that's really clear. And finally, number 4, y2 minus y1, that's 16 plus 10 over 8 plus 12. That equals 26 on top. It equals 20 on bottom. Divide those both by 2, you'll end up with 13 over 10, and there's your slope. Now, before I change slides, I just want to remind you, you should have written down everything that is on this slide, not just what is written in red, but the original directions that you see here, as well as the original ordered pairs that you were provided with, okay, numbered off just like they are on the notes. So if you need to pause at any point and fill in that information, you can. I'm going to go ahead and move on to the next slide. All right, numbers 5 and 6 are a little bit different. These questions were highly missed on the final, like more than half of us. So take a look. It says, use your knowledge of the slopes of parallel and perpendicular lines to answer below. Both of these are multiple choice questions, just like you saw in the final. In fact, one of these I think is directly from the final. I can't remember which one, but let's look at number 5. In number 5, it says, which line is parallel to the line given below? And here's the line. Okay? Now, right away, we should know that parallel lines have the same slope. Once again, I do want to remind you that everything you see on this slide should be written down in your notes, including these bold directions, the original question, this right here, and the 4 answers. So make sure to pause if you need to, okay? So remember that parallel lines have the same slope. Well, the slope of this line is -4/3. However, when we look at our 4 answer choices, they are not in slope-intercept form. So we need to find which one of these answer choices has a slope of -4/3 by converting it into slope-intercept form. Each of these are in standard form. So as I look at the first one, right, imagine that I wanted to get this in slope-intercept form. Well, what I would do is I would subtract 3x from both sides. I would have -4y equals -3x minus 28. And right away I can tell this one's not going to work, because then if I divided everything by -4, the slope I get here does not match what I had here. So this one, A, does not work. Okay, let's try the next one. If I try this next one, you're also going to notice that it's not going to work. Watch what happens, right? If we subtract the 3x, we get 4y equals -3x plus 8. If we divide by 4, right, I can show it here if you want to see it, we get a slope of -3/4. Also not what we want. So it's going to have to be answer choice C or D. We know we need a -4/3. Let's watch what happens in our third option. In our third option, if we subtract 4x from both sides, we have -3y equals -4x plus 9. If I divide by -3, you'll notice a negative divided by a negative gives us a +4/3, not a -4/3. So answer choice C can't work. It's got to be answer choice D. And we can confirm that, right? If you subtract 4x from both sides, you'll have 3y equals -4x minus 15. Divide by 3, there's the slope we were looking for. Okay? So keep that in mind. Now in number 6, again, make sure you've written down, the question number and the original directions, as well as this equation right here. We want to know which line is perpendicular. Now remember, perpendicular lines have opposite reciprocal slopes, right? Opposite reciprocal, which means flip the fraction, switch the signs. So we are looking for a line whose slope is not 5/2, but -2/5. Okay? So as we look at that, we want to consider, we want 2 to be on top and 5 to be on bottom. As I think about that then, that would require me to subtract a 2x and then divide by a 5. Already then I can tell that B and D are not going to be quite right for that. Those would require me to subtract a 5x and then divide by 2. So I know it's got to be A or C. Now I want to get the sign right. If I tried A and I subtracted the 2x, I'd have -5y equals -2x plus 25. If I divide everything by -5, I'm going to end up with a positive slope, since that's a negative divided by negative. That's not what I want. So it's got to be answer choice C, which we can see worked out here if we had 5y equals -2x minus 40, and then we divided everything by 5. You can see we get that -2/5. Okay. Again, before I change slides, I want to remind you, everything on this slide, including the directions, should be written on your notes to receive full credit. Okay, let's go on to the next one. As we look at number 7 and 8, each one has a different set of directions. So take a moment, pause your video. You want to make sure that you actually graph this line here. I'll help you out by plotting a few points. In this first line, there's a point right here at 0, -2, and there is another point right here at -3, 3. So take a moment and recreate that graph. This graph over here has a vertical line. You don't really need any points on it, but I'll just plot 2 random points, one right here and one right here. So take a moment, recreate those. You can pause the video if necessary. All right, in number 7 it says, if another line is perpendicular to the line shown on the graph, what must be its slope? So let's identify here. They're looking for a perpendicular slope. Well, let's first find the slope of this line. Remember, rise over run. So We rise, we go down 1, 2, 3, 4, 5. So that is down 5. And then we go to the right, 1, 2, 3. That means we have a slope of negative 5/3. But if I am looking for something that is perpendicular to that, I need to flip the fraction and then switch the sign, which gives us a positive 3/5. Positive 3/5 would be a perpendicular slope to negative 5/3. Now here, this one is a little interesting. We have a vertical line, and hopefully you remember a vertical line has an undefined slope, which means if you wrote it out, you'd have a 0 in the denominator. In fact, we can show that. The rise here from these two random points, I go up 1, 2, 3, 4 points, 4 positions. My run, I don't go left or right. It's like 4 over 0. Now think about what would happen if we want to find another line that is parallel to this line. Well, the slope is already undefined, so if we want to find something parallel to that, it would also be undefined. Okay? All right, let's go on to the next one. Again, I just want to remind you, everything on this slide should be written down, including the directions, including the graphs, and including what I've written in red. All right, let's look at our last set of questions here. It says, write the slope-intercept form of the equation of the line described. Again, pause the video if you want to write all these directions out before we begin. In number 9, it says we're looking for a line that passes through the point 4, 1 and is parallel to the equation y equals 1/2 x plus 5. Well, remember, point slope form, right? In fact, out to the side, it might be worth writing it down. Point slope form. Point slope form is really helpful to us. It's y minus y1 equals m parentheses x minus x1. Remember, for point slope form, the name tells you exactly what you need. You need a point and you need a slope. In each of these questions, they have provided you with a point. That's not going to be a struggle. The question is getting the correct slope. So let's begin with this. We have our point right here. We can see this will be x1, this will be y1, and then we're told that our new line will be parallel to this given line. That means same slope. Same slope. So we will use 1/2 in our equation. So let's go ahead and do that. All right. There we go. All right, so we'll write y minus 1, that's our y1, equals m, our slope, 1/2, parentheses, x minus 4. They do want us to write this in slope-intercept form, so we need to get y by itself. Our next step would be to distribute the 1/2 to everything in the parentheses, so that we have y minus 1 equals 1/2 x minus 2, then add 1 to both sides, so that our final answer will read y equals 1/2 x minus 1, because if you add 1 to -2, that gives you -1. All right, let's try the next one. What's interesting about the next one, though, we're still looking at something parallel, but our original equation is not in slope-intercept form, so I don't know what the slope of this line is just by looking at that. So before we begin, we need to convert our given equation into slope-intercept form. So let's do that. Well, first let's subtract 7x from both sides. We'll have -y equals -7x plus 5. Now, that almost looks like slope-intercept form, but there's a negative out in front of the y. So we're going to divide everything by -1 to change the sign. And that will give us y equals a positive 7x minus 5. So we can see the slope of our line in this case is a positive 7. And we're looking for something parallel to that. So there's our slope, here's our point. Now we can begin. Let's use point slope form. Y minus y1, in this case that's y minus 2, equals our parallel slope of 7, parentheses, x minus 4. We'll go ahead and distribute into the parentheses. When we do that, we'll have y minus 2 equals 7x minus 28. Then the final step will just be to add 2 to both sides so that y is by itself. We'll end up with y equals 7x, and if we add 2 to -28, we'll get -26. There's our answer right there. All right, last two questions. You'll notice that in each of these two questions, we are told that our new line is perpendicular to the given line. So we need to make sure to flip the fraction and switch the sign to get our new slope. For example, in number 11, again, make sure you're writing down all the given information. In number 11, the slope provided is 1/2. Therefore, the perpendicular slope would be -2/1 or just -2. There is our slope, or m. Now we can go ahead and use point slope form. Let's go ahead and do it. Y minus y1, that's y minus -4, so y plus 4. That equals our new slope, which is -2, parentheses x minus 1. Now we'll go ahead and distribute into the parentheses. We get y plus 4 equals -2x plus 2. And then we need to subtract 4 from both sides. We get y equals -2x minus 2 when we subtract that 4. And there is our equation that is perpendicular to the given line but passes through the point 1, -4. And then our final example here, right? Make sure you're writing down the original directions as well as all of my work. Here we go. We have a couple of problems here. First, this is in standard form. I don't even know what the slope of that line is, so we're going to need to convert this into slope-intercept form. Let's begin by subtracting 3x from both sides. We get 8y equals -3x minus 8. Then we divide everything by 8. And when we do that, we can see what the slope of the original line is. The slope of the original line is -3/8, but we want something perpendicular. So flip the fraction, switch the sign. Our new slope will be +8/3. That is our slope. And of course, we can see our ordered pair is 3, 3. So let's go ahead and substitute this in to point slope form. So y minus 3 equals our new slope of 8/3, parentheses, x minus 3. We'll go ahead and distribute. We get y minus 3 equals 8/3 x minus 8. And then finally, we need to add 3 to both sides. So our final answer is y equals 8/3 x. And when you add 3 to -8, you get -5.